Okay, the second time. Let's try. So yeah, everything I will say is NFA, non-financial advice, and do your research, like everything. So let's go. The problem right now is that as Web3 developers, we have to create applications for billions of users, right? And the thing is, the existing infrastructure is not going to do that. So we have to create infrastructure which is scalable, convenient, and secure. But most important, scalable, of course, because it's already secure somehow, and I'll show you how. Right now, if you look at the TPS, transactions per second, the Ethereum, you will find that it somehow reached its all-time high. It's around 15 TPS per moment. And a few years ago, we had some spike of alternatives layer ones. So some users were able to work with applications on Binance Chain, Polygon, whatever, and other chains. But the most secure environment is still Ethereum, right? Because like huge miners network and the huge capital load there. So we have to somehow scale it. But the thing is, we cannot avoid this scalability dilemma, right? Because we can only pick one side. We can do something scalable and secure, but not decentralized. For example, Solana. or we can do something scalable and decentralized, but why? It's not secure. Or we can choose security and decentralization, but it's not scaling, like Ethereum main chain, right? So today I will relay on Twitter threads of this guy. His tech is Salon Crypto. His materials, mostly infographics, are amazing. So if you want to double check the infographic, just find him and read the threads. So the thing is how Ethereum can be scaled. There were many attempts to do that, started from the state channels and the plasma, but both are dead because basically they are not used by anyone. Why? Because they were specific for transactions of tokens, but not for general scaling, like different applications. And right now we have hype around optimistic labs, and in the future, probably, there will be ZK labs. So we'll see how it works. And of course, Rollups letting Ethereum to be scaled for like 100,000 of transactions per second, which is important for us. And at the moment, we have like temporary, but we have something like Rollups Freedom. What we have here, we have security, we have fast L2 withdrawals, the way how you are unlocking funds from the layer 2, and we have EVM compatibility, right? And we also can choose only one side here at the moment, of course. And if you heard about ZK Rollups, you can find a lot of applications like Blueprint, Starkware, etc. Those are ZK Rollups. They are secure and fast L2 withdrawals, but they are not EVM compatible. It means that those chains, they are app-specific chains, mostly. And at the moment, we have another area. We have optimistic rollups, and you can find Optimism or Bitrumetis, GTON rollup, or BOA. Those are optimistic rollups, and those are the area of main activities, actually. Most of the dApps are launching there, activity is growing there. And but don't try to choose fast L2 withdrawals and EVM compatibility right now because it's not So basically, there is no ZK rollups which are EVM compatible yet. Probably this will be in the future. But if you try optimistic rollup to be fast with the fast withdrawals, those will be unsecure because we need some time, and I will explain why. So ZK rollups. ZK means zero knowledge, and the thing is I cannot explain how it works. Basically, no one is able to explain because it's magic. You can just replace everything like ZK proofs or ZK rollups to magic, and you will not lose the sentence of what's written because it is algebra, and as I told you before, it is not solved for EVM compatibility. But optimistic rollups, those are working really well. And optimistic rollups, they have 4 main features, like instant deposit. You can just deposit some funds on the rollup. There is centralized, mostly execution environment for transactions. This is why it's fast. Remember the trilemma, right? So, but we have some cryptographic magic here to actually restore the state of the rollup into the main chain, and then we have withdrawal. And withdrawal has some change period used to 1 week to verify that all the computations on rollup, because they can be centralized, those are valid and those are stored in the layer 1. And yeah, again, how Rollups works? User deposit funds into the smart contract, right? So this is on-chain transaction. This is why it can be instant, like just Ethereum verification. After that, we have magic machine called sequencer. All the transactions, like hundreds or thousands TPS per second, transactions per second, can be perceived with this sequencer, and this is environment in terms of like user experience exactly the same as Ethereum, because it's basically RPC node. User is connecting to that. User interacts via MetaMask or another Web3 wallet with that, and all those transactions relating to the user addresses and user cryptography. But every second or every 10 minutes, whatever, depends on the implementation. We have state, which is storing into the main Ethereum net. So on this visualization, you can find the blue blocks; those are Ethereum mainnet, right? The green blocks; those are rollup blocks. And every period, we have state dump into the Ethereum mainnet. With some magic, and this magic coming from the tricks with data compression. Here you can find how the data can be compressed, and in the end, the user is withdrawing the funds. We have unlocked all the funds on the mainnet, right? On the mainnet. So the magic behind this is connected with the cryptography, starting with the simple hash functions. Hash functions just encoding of any text data into the string, into the random string, and Merkle trees. The Merkle trees is a bit more typical thing, but also pretty easy to understand. You have sentence of transactions, right? 1, 2, 3, 4. From each transaction, so you're able to create a hash, right? But on top of that, you can also take a hash of 2 hashes, right? And then go up and up. And you will have the Merkle root. The Merkle root basically is hash of hashes going up. And the thing is, this data is pretty important, because if you try to change something, your Merkle root could be also changed, right? But if data wasn't changed, the Merkle root will be the same. And this is important approach for verifier, because I told you before, we have Merkle roots of every state from the rollup, right? And using this data and using those hashes, anyone is able to verify that the transactions and the data of those transactions were exactly the same as it was on the rollup. It means that rollup wasn't changed, wasn't attacked, wasn't hacked, and this is how the verifier works. And this is why, when we are talking about optimistic rollups on any rollups, we are saying that rollups, even if the sequencer can be centralized, the rollups states are basically relying to the security of the mainnet of Ethereum, right? So those are secure, and this is like trade-off between the mainnet of Ethereum security, which is like most secure at the moment, and the speed of execution. So we have optimistic rollups and pretty easy tricks. I hope this was simple to understand. Again, we still have this thing unsolved. Right now, we have hype around optimistic rollups. Later, I hope there will be ZK rollups, because we have one thing which is not solved by optimistic rollups yet, the fast L2 rollups. And Speaking about GTON rollup, we are optimistic rollup, but we have one important feature, and the feature is the decentralized stablecoin as native currency for rollups. I will explain about the stablecoin a bit later, but speaking about rollups, I can say that we have two different models of optimistic rollups at the moment. We have rollups which are using Ethereum as gas currency for rollup itself, right? So basically, the users who are spending Ethereum on rollup, they are paying for sequencer for its work. We have another type of rollups which are using another tokens, not Ethereum. Those are Metis or GTON network. Metis is using its own token, but GTON is using the stablecoin, which we think is more convenient for users to use because it's basically stable. They are not risking by holding this asset. And our stablecoin is basically decentralized stablecoin, which means that to issue one GTON dollar or GCD, you have to lock some amount of Ethereum or GTON, and you will have the stablecoin. Then doing that on Ethereum, you can bridge stablecoin on rollup and use this stablecoin as a gas currency on this rollup. So pretty simple model, right? And we are already in alpha. We are in mainnet, but we can do roll back anytime. So it's a liquid visit at the moment, and that will come soon. We already have chain ID, which is 1,000. I really like it. And yeah, if you want to know more, you can just scan the code, or you can find the presentation in the chat. I will wait 2 seconds. And yeah, so basically you can find me on Twitter or in Telegram, and I will explain anything. We have our GTON Academy used to every week online. We are inviting some guests from the industry to cover some topics, mostly DeFi topics, but also infrastructure talks. And yeah, so thank you so much for having me here and ask any questions.
What's the difference between the two most used types of stablecoins? Like having USD, the Tether, they say they have dollars to back it up. You know what happened with Tool 1? It's getting arrested right now.
Yeah.
It's like focused on algorithms. How do you classify your stablecoin?
There are 2 types of stablecoins on the market. Centralized stablecoins, which are Tether, USDT, Circle USDC, and Binance, right? Binance Dollar. Those are simple. They have binary one, or pretending to have it, right? The second one is algorithmic stablecoin, which is Terra Luna, right? Or Frax, or USDM. The problem of algorithmic stablecoins is that they are not over-collateralized. They have crypto as the collateral, but there is no guarantee that this crypto collateral will not go to zero, right? And exactly what happened with Terra Luna. The more important thing is, and probably has much more potential, is crypto collateralized stablecoin or decentralized stablecoin, as we can see. Those are, for example, DAI, MEME, LUSD, etc. The difference is that the decentralized stablecoins or crypto collateralized stablecoins, they are using over-totalization model to issue the token. This is one thing, and another thing, most often they are using multi-collateral. So if you have 2 things, over-totalization and multi-collateralization, you are actually preventing the risk of death spiral. Because Terra was dying because of the spiral, right? How the spiral works. There is the effect of stablecoin, like it's cost $90. People start seeing arbitrage. Do the arbitrage, they are selling the collateral asset. The collateral asset is going down, the price is going down, because people are selling it, right? Which is causing more and more issue with the collateral itself. And this is how the spiral works. Then you have crypto collateral stablecoins with a multi-collateral. Those multi-collateral assets, they are not related if you are properly managed to diversify the collateral. For example, you can have Ethereum as a collateral, Bitcoin, digital gold, for example, Pax Gold or Tesla Gold, whatever, or even dollar. because you can use USDC to issue DAI, for example, right? And those are not related. So it's preventing the death file because you can liquidate different collaterals. Another thing is overcapitalization. If you look at the diagram, you will find that you have to use $150 of collateral to issue $100 of stablecoin, which is creating some kind of buffer against price volatility, right? So using those principles, you can design the stablecoin. So
I have a quick question.
yeah.
Can you build an application on optimistic rollup but have it invocable from the mainnet? Like, for example, the RSVP that's built on optimism. Can I try to do something with it from my Ethereum mainnet wallet?
Of course. The thing is, you don't have to do that because on Rollup you are not spending same fees as you are doing that on the mainnet, right?
So like he's saying, you can execute transaction on the rollup from mainnet. Yes, you can by sending call data.
Yeah, you can interact with the rollup. Basically, the rollup is absolutely isolated environment, right? It's just keeping its state in the mainnet. So it's basically like another chain. You can do any cross-chain operations only if you have the bridge or cross-chain communication layer protocol between them. So this is the only way because basically the rollup and the side chains or alternative chains, those are another environments. The only difference is the rollup state is stored in the mainnet and can be restored in any environment from the mainnet. Yes.
So when you compare with DAI, with no friction or easy to use bank dollar, why would a person pay premium for your stablecoin? Why would it make sense to give $50 more if you want to have $100?
The thing is, you are not exchanging it. You're just locking your funds, right? Imagine you have Ethereum and you have $150 of Ethereum. You don't want to sell it, right? Because you think it will grow up in a few months. So, but you need some liquidity. You want to invest in somewhere, you want to trace, you want to use your liquidity. Because if you don't want to sell your ETH, you have no liquidity, right? So you can lock it somewhere, get a stablecoin and do transactions. You can farm something, you can invest in something, you can do whatever you want with the stablecoin, right? So, but then you did your operations with liquidity, you can exchange it back to exact amount. For example, if you lock one Ethereum, you can exchange it to one Ethereum, minus a little fees, of course, the protocol fees, but you can exchange it. Despite the fact how Ethereum costs right now, it can be 10 times higher. This is the difference.
You get fees out of the rollup.
No, we have different models. This is how I push call the protocol, the wire capturing protocol for the whole system. Yeah.
So there's a chance of me losing my extra $50.
If Ethereum will go down, yes, because there will be liquidation. So if you have collateral, for example, you issued $100 with your 150, right? But Ethereum went down, and the collateral worth less than $100. So this is the time for the execution. Actually, the time for execution will not be after the $100. It will be $110 or something because you need liquidation fee for participants to get profit from that. So if the Ethereum price goes down for like 50%, of course you will be liquidated. But you have your stablecoin, but not collateral. So this is how it works. So basically, like passing collateral loan.
But even for the DAI, 80%, 150%, even for the DAI,
It depends. It depends. It's the protocol settings. So, for example, if you are using USDC as a collateral, you don't have to lock 150 USDC to issue $100, right? You have to lock, I don't know, $102, just $2, against the volatility. If you're using volatile assets, I don't know, let's mention link, for example, of course the capitalization ratio must be higher, like $300 to each 100, because you know the markets are volatile, and those parameters depends from liquidity and volatility of the assets.
So you are having the same setup.
Yes, of course. Mostly those things are solved by governments, by so-called governments. Like there is a proposal with the explanation, like we're gonna add a new collateral. This collateral has this volatility, this liquidity, so we think that the collateral ratio must be higher. And then there is a community mode. The token holders, they are expressing their opinion about that. So
It works like any collateral.
any, but I don't suggest to use long-tail assets as a collateral because you cannot liquidate them. If you cannot liquidate something, you can face some liquidity issue, some deficit issue. It's actually happened 2 years ago with a DAI because it was crashed during the COVID. So guys, if you have any more questions, kindly ask anything, and thank you so much. I think it's automatic.